This is the part 2 of chapter 1 real numbers. Today we are going to cover exercise 1.2, and the first problem in this exercise is express each of the following numbers as a product of its prime numbers. So the first one is 140. For a given number, మనం prime factors find చేయాలి. For that we will use the prime factorization method. This we have covered how to do a prime factorization for any given number in the introduction video, that is part 1. You can watch that video in my channel, and also I give that playlist in the description box. So ఈ prime factorization perform చేశాక 140కి we will get the prime factors. These are the prime factors. To express the number 140 as a product of its prime numbers, we must perform prime factorization. So after performing the prime factorization, what are all the numbers that we are getting here are the prime factors of this number that we have expressed in the form of the products, that is 2 into 2 into 5 into 7. Therefore we can express 140 as 2 to the power of 2, because 2 is appeared 2 times here, that's why it is 2 to the power of 2, and 5 into 7. This is how we represent 140 as a product of its prime numbers. And the second problem is find the LCM and HCF of the following integers by using prime factorization method. Prime factorization method, this basically gives us the prime factors of any number. So individually మనం 12, 5 and 21కి ఫస్ట్ prime factorization perform చేయాలి as shown in this image, and then the prime factors that we have obtained must be written as a product. Here we can see 12, 15 and 21 were expressed as a product of their prime numbers. Here you can observe I have highlighted the number 3 because it is appearing in all the prime factorizations of 3 numbers. So this is the HCF of 12, 15 and 21. The highest common factor is the number that divides 3 of the numbers evenly without leaving any remainder. So 3 can divide 12, 15 and 21 evenly. So this is the highest common factor of these numbers. And to find the least common multiple, firstly we should take the highest common factor as it is, and then we have to multiply all the remaining values from the prime factorization. 3ని వదిలేసి మిగతా నంబర్స్ అన్నిటినీ, like here 2 to the power of 2 and 5 and 7, ఈ 4 valuesని multiply చేసి, and we are also keeping this HCF as it is. When we multiply all these values, we will get the LCM for 12, 15 and 21. You can follow the same procedure to solve next problems in this question. If you have any doubts, you can comment down and I'll try to solve them in the next video. And the next question is, check whether 6 to the power of n can end with digit 0 for any natural number n. సో ఇక్కడ ఏమంటున్నారంటే 6 to the power of n అంటే if we keep any value for n like 1 or 2, 3, 4 any number, whether it can end with digit 0 or not. So first, if a number should end with 0, it must be a multiple of 10. ఒకవేళ number that must end with 0 అంటే it is a multiple of 10 అని అర్థం కదా. So if 6 to the power of n must end with 0, then it must be divisible by 10. If we consider the prime factors of 10, it will be 2 and 5. Now let's check the factors of 6 to the power of n. If we look at the factors of 6, there will be 2 and 3. We cannot find 5. Prime factors of 6 to the power of n does not contain 5. In the prime factors of 10, we can see the number 5, right? That cannot be found in the prime factors of 6. Therefore 6 to the power of n cannot end with 0 for any natural number n. Moving on to the next one, Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Firstly, what is a composite number? The number which is not a prime number. Prime number ante enti? It should have only two factors. That is, a number ni no other table can divide. That means the factors of that number should be 1 and itself. That's it. No other number should divide the number evenly. If we consider the first case, so here we can consider this as one part and this as another part. From this we can consider 13 as a common number. So I am taking 13 and writing the remaining 7 into 11 separately. And if we take 13 common, here we are left with 1. So if we multiply this, we will get 77 and 1 is written as it is. This can be solved as 78. We will left with 13 and 78. Since the number can be written as product of two integers that are greater than 1, 13 and 78. So this whole number can be written as product of two numbers that is greater than 1. ఈ రెండు numbers అనేవి greater than 1. So what we discussed, prime factor should have only two factors, that is 1 and the number itself. But here 1 కాకుండా there are two different numbers which are greater than 1. So this cannot be a prime number. If this cannot be a prime number, therefore it is a composite number. The similar process is implemented for this example. Hence this also can be expressed as a product of two integers that are greater than 1. This number also cannot be a prime number. Hence it is a composite number. Now how will you show that 7 into 11 into 2 plus 7 into 11 into 5 is a composite number? To explain this, let's take the given equation. This can be expressed as, so here we can observe that 17 and 11 both are common in these two separate parts. If we take it common, we will end up having 2 and 5. So if we write 2 and 5 and add them, we will get 7. Here we are expressing this equation as product of three integers. This whole expression is here expressed as a product of three numbers. So if it is a product of three numbers which are greater than 1, this can never be a prime number. Prime number ante it should have only two factors, but here there are already three factors which are also greater than 1. So this can never be a prime number. Hence it is a composite number. And the last question of this exercise is, which digit would occupy the unit space of resulting number of 6 to the power of 100? To know this, first let us understand the pattern of powers of 6. Here if we take 6 to the power of 1, the answer will be 6, and 6 to the power of 2, the answer will be 36, and so on. Here we can observe a pattern where every power of 6 is ending with 6. So if we follow the same pattern, we can see that the unit digit is always 6 for any positive power of 6. Hence the unit space of resulting number of 6 to the power of 100 is also 6. Thank you for watching the video. If you find the video informative, please do like the video and subscribe to my channel. Share with your friends, and if you have any doubt, comment down in the comment section and try to solve them in the next video.